After successfully creating controlled signals for different factions, Kai and Orion discover a hidden underground lab beneath the bustling market. Orion explains the importance of sensing environmental changes to avoid detection.
This looks like a good place for a hideout, Orion. What's our next move?
Kai, we need to secure this place first. For that, we need to sense environmental changes to detect intruders trying to get inside this underground lab. Today, we'll learn how to use a photoresistor to control an LED based on light levels. This will help us create a light-sensitive alarm that will notify us whenever an intruder passes by.
A photoresistor? What is that? How does that help us?
A photoresistor will allow us to detect light levels. It converts light levels into electrical signals. We can use this information to create a light-sensitive alarm, enhancing our ability to safeguard our base.
Let's get started.
First, we need to prepare the components we need for this project. We need the Pico W breadboard, LED, 220 ohm resistor, 10 kilo ohm resistor, photoresistor, and some jumper wires. Gather your materials and prepare your workspace.
Okay, I've got everything we need. What's next, Orion?
First, we need to wire the LED circuit. We'll connect the long leg of our LED directly to pin GP15 of our Pico and connect its short leg to our ground rail, which is connected to our Pico W's GND pin using a 220 ohm resistor. Now let's set up our photoresistor circuit. Place the photoresistor on our breadboard and connect one of its leg to the ground pin through a 10 kilo ohm resistor and connect the opposite leg to the 3.3 volt power pin of our Pico using a jumper wire. The ground side of our photoresistor will be connected to our Pico W's GP26, which is also the ADC pin.
What does the ADC pin do? And how will this photoresistor work? I've got a lot of questions, Orion.
A photoresistor, or light-dependent resistor, LDR, changes its resistance based on the light intensity. This resistance value are then converted into an analog signal that our Pico W can understand. Analog signals are totally opposite to the digital signals that we used before. Digital signals are basically just on and off, while analog signals are giving specific values which give our Pico W an information on how bright or dark the area is.
Got it. I understand it now. It's connected. What's next, Orion?
Open Thonny IDE and ensure the Raspberry Pi Pico W is connected. Select MicroPython Raspberry Pi Pico as the interpreter, just like what we always do. Now, write the following code to read the light levels from the photoresistor and control the LED. Let's break down this code step by step, Kai. First, we import the necessary modules. Pin is for controlling the GPIO pins, ADC is for reading analog values, and time is for adding delays. Next, we initialize the LED and the photoresistor and set their respective pin as an output and an input. The while true loop runs continuously, allowing us to read the light levels and control the LED in real time. This line reads the analog value from the photoresistor and stores it in the light level variable. This line prints the light level reading from our photoresistor to our Thonny IDE console. Printing the light level is optional, but it helps with debugging by showing the current light level in the console. We use this if statement to control the LED. If the light level is less than 20,000, the LED turns on. Otherwise, it turns off. This line adds a half-second delay between each reading, making the loop run smoothly.
Thanks for explaining, Orion. I think I understand it now.
Now run the code and see if it works. After clicking the Run button, cover the photoresistor using your hand and see if the LED reacts. If it does not, we need to check the value that is printed on our IDE console and adjust our if statement based on those values.
It's working, Orion. I think this will be a huge addition to our security system. We should install this immediately.
Today, we learned how to use a photoresistor to sense light levels and control an LED. This skill will be essential in our mission to save Neon City. Are you ready for the next challenge, Kai?
Absolutely, Orion. Let's prepare for our next adventure and save Neon City.